question 717, which is titled More Congruence Charts. We're going to answer the question, are the triangles congruent? So question 775 says, Jessel started to prove that the triangles at right are congruent. He was only told that point E is the midpoint of both AC and BD. Okay, so this word midpoint is two words put together, and it's kind of obvious what they are. Mid stands for middle, and point stands for point. Okay, so it's the point that's in the middle of the line segment. So the first line segment is AC. So from A over here to C over here, E is in the middle. If it's exactly in the middle, that creates two congruent parts. So I put a tick mark here and a tick mark here, creating two congruent parts. Okay? It's also the midpoint of BD. So on BD, if that's the midpoint, it creates a smaller piece right here, congruent to the smaller piece right here. And I put double tick marks on both. Okay? That creates a side congruent to a side and a side congruent to a side. So far we have side, side. Is side, side enough to prove triangle congruence? Is that one of the ones from yesterday? So side, side's not enough. So we either need side, 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 or we need side, angle, side. So the angle in between them, because if it's before it or after it, it's going to spell a bad word, right? Or side, side, side. All right, so let's see what we can do. Let's look at this angle right here in green and this angle right here in green. Is it possible that those two angles could be congruent? Yes, does anybody know what those two angles are called? Yes, sir. They are acute because they're smaller than 90, but I'm looking for something a little more specific that has to do with their relationship to each other. Yes, they are vertical angles. So this angle and this angle end up being congruent because of something called vertical angles. All right, so part A says to complete the flow chart below, be sure to fill in any missing arrows and fill in the reason to provided for every statement. Okay, so the first thing we did is we took the statement that they gave us about the midpoints, and then we're going to translate in that into BE is congruent to DE, where I put the tick marks, the single tick marks. Oh, the double tick marks, this one and this one. Then we've got the two angles in the middle, angle AEB and angle CED, congruent because of vertical angles. And then AE is congruent to CE because of the single tick marks. Make sure you fill in the reasons. This one was definition of a midpoint. This one's vertical angles. That's going to give us the two triangles congruent by side, angle, side. Okay? Part B says, what series of rigid transformations would map triangle AEB onto triangle CED? How can we get from the triangle on the left to the triangle on the right? I'll give you a hint. It looks like one thing, but it's really something else. Anybody think they know? From here to here. Dennis? A rotation. Good. So if you do a 180-degree rotation at point E, you're going to take that left triangle, turn it, it's going to end up on the triangle on the right. Okay? Notice that the single tick mark has to end on top of the single. The double has to end on top of the double. So if you just do a reflection, that's not going to happen. Okay? Question 776 says, for each pair of triangles, determine if the triangles are congruent by organizing your work in a flowchart. Label the vertices if needed. If the triangles are not congruent, or there is not enough information to determine congruence, then you're going to write cannot be determined. All right. So for part A, I went ahead and labeled the vertices A, B, C, D. Go ahead and do that on your paper right now so that we're talking about the same places. All right. That is the third piece of information, right? Yes, okay. All right, so the first thing that we notice on these, on the lower triangle and the upper triangle is that there's a tick mark here and a tick mark here. So the tick mark indicates congruence. So we're going to say that AB is congruent to CD, and that's given. Because of the tick mark, it's given. Okay. The next thing that we see is this little arrow that we call a caret. So this caret and this caret right here. Does anybody know what the carets mean? Okay, so this is a new symbol. It means that the two lines are parallel. So not only are they congruent, they're also parallel. So in between the AB and the CD, we're going to put this double stick. That little double stick symbol means that they're parallel. All right, so if these two lines are parallel, and then we have this third line going through them, that's called a transversal. How many of you learned about a transversal in 8th grade? A couple people? Okay, so a transversal and two parallel lines creates special angle relationships. So if it's between the two lines, it's called interior. And if it's on opposite sides of the transversal, it's called what? No, exterior would be outside. They're interior, but they're on alternate sides of that transversal. So those two angles are going to be congruent to each other because of something called alternate interior angles. Alternate interior angles. Right? So if we have the side over here and then the angles that are marked in pink, we're looking for one more thing, and that's AD is congruent to itself. So AD is congruent to AD. That's the shared side. That segment in the middle is both a part of the top triangle and the bottom triangle. So it's congruent to itself. It's called a shared side. Just so happens that that angle is in between the two sides. So we have side, angle, side, side, angle, side. So we're going to say that yes, the two triangles are congruent, and the reason is side, angle, side, triangle congruence. Okay? Part B, I labeled the triangle EFGH. So go ahead and do the same on your paper. So we're talking about the same thing. And you're going to notice there's a double tick mark here and a double tick mark here. So that's a side, right? That's an S. Then we've got this angle over here and this angle over here. That's an A, right? We also have the shared side, the FH. See FH down the middle? It's part of both triangles, the left triangle and the right triangle. So we have another S. But let's look at the order for a second. We've got this angle, this side, this side. This angle, this side, this side. We've got angle, side, side. That spells a bad word. Angle, side, side. Picture that in your head. Angle, side, side. Does that work?
What word is it?
Right? Yeah. So you're going to say that side, side, angle is not valid. It does not work. SSA. Right? You want me to say it out loud? I don't talk like that. Yeah, it is. You could, yeah, it could be a mean animal. All right. Yes, true. Okay, so now let's look on the next page. So on page 16, we've got similar to B. We've got this angle that's 47 and this angle that's 47. That's our first A. Then we've got this angle that's marked congruent to this angle. That's our second A. Then we've got vertical angles in the middle. That's our third A. Does A work? No. Angle, angle, angle does not work. It could, but we don't know for sure because there's no sides marked. No information about any of the sides, okay? They could all be congruent, but we don't know. So we just say that it's not valid. All right, part D. Please label the vertices A, B, C, and D. First thing you're going to notice is the single tick mark here and here. So you're going to say that AB is congruent to AD. That's given because of the tick marks. The second thing that you're going to notice is that BC is congruent to CD because a double tick mark here and a double tick mark here. The reason is that it's given. The third thing that you're going to notice is down the middle, as part of both the top triangle and the bottom triangle, is side AC. It's congruent to itself because it's a shared side. It's part of the top triangle, it's part of the bottom triangle. So we have side, side, side. Is side, side, side enough to prove triangle congruence? Yes, it's one of our congruents. So we say that the triangle ABC is congruent to triangle ADC by side, side, side. All right, part E is already labeled at the vertices, good. And we have this special little symbol again, this little caret that we saw way back in what, part A? That means what? Parallel. So this line and this line are parallel, and here's your transversal. Transversal is going to create these alternate interior angles, and they're going to be congruent to each other, okay? The other thing we've got is angle A is congruent to angle C because of those tick marks, and we have this shared side. DB is part of the top triangle and part of the bottom triangle. So we're going to take those three statements. AC is congruent to each other. That's given. AB is parallel to CD. That's going to make our alternate interior angles congruent. And then DB is part of the top and the bottom triangle. That's a shared side. Now we just need to check out our order. We've got angle A, angle ABD, and then a side. Angle C, angle CDB, and then a side. So that looks like angle, angle, side, angle, angle, side. Is angle, angle, side going to prove congruence? Yes, that's one of our ones that works. So we say that the two triangles are congruent, and the reason would be angle, angle, side.